Welcome to EDO Aero Classroom. In this tutorial, we will discuss binomial theorem and some results based on binomial theorem. Firstly, we will discuss what is binomial theorem. Binomial theorem says that if x and a are real numbers, then for all n belongs to natural number, we have x plus a raised to n will be equal to summation of r is equal to 0 to n ncr x की power n minus r into a की power r. So this is the binomial theorem, that is x plus a raised to n will be equal to summation of r is equal to 0 to n ncr into x की power n minus r into a की power r, that is expansion of x plus a raised to n. Or we can say that x plus a raised to n will be equal to nc0 x की power n a की power 0 plus nc1 x की power n minus 1 a की power 1 plus nc2 x की power n minus 2 a की power 2, so on to ncr x की power n minus r and a की power r plus so on to plus nc n minus 1 x की power 1 a n minus 1 plus ncn x की power 0 into a की power n. So if we expand this formula, this is equal to this one. So this is the mathematical formulation of binomial theorem. That is, it says the expansion of x plus a raised to n in the form of combinations and variables. Now we will discuss some results based on binomial theorem. First result is the total number of terms in the expansion of x plus a raised to n is n plus m. Second result is, as we know that since ncr is equal to nc n minus r by the property of combination for r is equal to 0 so on to n, so nc0 will be equal to ncn, which implies that, or we can say that ncn minus 1, that is nc0 is equal to ncn or ncn minus 1, or we can say that nc2 will be equal to ncn minus 2. This is the second result. Now let us discuss third result. Third result is expansion of x minus a raised to n will be equal to summation of r is equal to 0 to n minus 1 की power r ncr into x n minus r into a की power r. In the expansion of x minus a raised to n, replace a by minus a in the expansion of x plus a raised to n. So we get the expansion of x minus a raised to n, which is this. Here one point is to be noted that the terms in the expansion of this are alternatively positive and negative. The last term is positive or negative according as n is even or odd. If n is even, the last term will be positive. If n is odd, the last term will be negative. Because we know that minus 1 power of even number is equal to positive 1. Minus 1 power of odd number is equal to minus 1. So accordingly, if n is even, so the last term will be positive. If n is odd, last term will be negative. Now next result is if we want to do the expansion of 1 plus x raised to n. So we can find out as replace a is equal to x and put x is equal to 1 in the expansion of x plus a raised to n. So by putting x is equal to 1 and replacing a by x, we can get the expansion of 1 plus x raised to n, which is equal to summation of r is equal to 0 to n ncr and x की power r. Now next result is, or one more point which to be noted in the previous result is that this is the expansion of 1 plus x raised to n in ascending power of x. And if we have to find out the expansion of this in the descending power of x, so we have to do the putting a is equal to 1 in the expansion of x plus a raised to n. So if we put a is equal to 1 in the expansion of x plus a raised to n, we get the term in descending power of x. In this case, 1 plus x raised to n will be equal to summation of r is equal to 0 to n ncr x की power n minus r. Next result is, that is, if we want to do the expansion of 1 minus x raised to n. So we can find out by putting x is equal to 1 and a is equal to minus x in the expansion of x plus a raised to n. We get the expansion of 1 minus x raised to n, and which will be equal to summation of r is equal to 0 to n minus 1 raised to r ncr x की power r. Next result says that the coefficient of r plus 1 term in the expansion of one plus x raised to n will be equal to ncr. And next result is the coefficient of x raised to r in the expansion of 1 plus x raised to n is also ncr. So these were the some results based on binomial theorem. Now let us see one example based on these results and binomial theorem. Before discussing the example of binomial theorem, two more results are left which are based on binomial theorem. Two results which are left are, that is, x plus a raised to n plus x minus a raised to n will be equal to twice of nc0 x raised to n a raised to 0 nc2 x raised to n minus 1 a square plus so on. That is consist of even powers of a and x. and if we want to subtract the expansion, we get the odd power, which will be equal to nc1 x n minus 1 a1, nc3 x n minus 3 a3 plus so. So in this we get even terms, or even in this we get odd terms. Also one more result is if n is odd, then this this one and this one have both same number of terms that will be equal to n plus 1 by 2. If n is even, then x plus a raised to n plus x minus a raised to n has n by 2 plus 1 terms, and x plus a raised to n minus x minus a raised to n has n by 2 terms. Now we will discuss example based on binomial theorem. In this example, we have to find out the number of terms in the expansion of this, and this. Firstly, we will solve first part, that is 2x minus 3y. As we know that number of terms in the expansion of x plus a raised to n is n plus 1. So here n is equal to 9. So number of terms in the given expansion will be n plus 1, that is 9 plus 1 is equal to 10. So this is the answer. In the second part, this is root 2 into 5 root 2 into x raised to n plus 5 minus 2x raised to n. Here we see that n is odd, that is 9. So number of terms will be n plus 1 by 2, which will be equal to 9 plus 1 by 2, that is 10 by 2 is equal to 5. By using the result of the binomial theorem, we find out this. In the third part, we have to find out the number of terms of this expansion. Further, we can factorize this factor, as we know that this is making the formula of x plus 1 raised to 2. X plus 1 raised to 2 into whole power of 20, which will be equivalent to x plus 1 raised to 40. Then the number of terms will be n plus 1 now. Here n is 40 plus 1 is equal to 40 members. So number of terms is 40. In this way, we can find out the number of terms by using the results of binomial theorem.